Welcome to our channel. Watch the video until the end. Leave a like and subscribe to support us.
Undoubtedly, they are the most terrifying phenomena in the universe. And now it may be discovered that black holes played a much more significant role in the young universe than previously thought. A new astronomical record has announced the incredible discovery of the oldest and most mysterious black hole in the universe. We must thank the ingenious new James Webb Space Telescope for this discovery. We now face very important questions because it's possible that black holes existed in the universe much before the appearance of the first stars and galaxies. But how these black holes formed or perhaps were already present before the Big Bang is still a mystery. Black holes might be the true key components revealing the entire truth about the universe. James Webb has discovered a black hole at the threshold of cosmic dawn, so enormous that all scientific theories fail to explain how it was formed. Since this ultramassive black hole was discovered, it has set new astronomical records. At over 13 billion years old, it certainly dates back to the dawn of the universe and is so massive that it contains the mass of billions of suns. Researchers have located this incredible discovery at the center of a very ancient and no less mysterious galaxy. The fact that black holes operate at the center of galaxies is not new, but a galaxy so large and an ultramassive black hole in the young universe are phenomena that actually shouldn't exist. Not if we continue to believe in the Big Bang and the estimates so far. Is it really possible that the universe is only 13.8 billion years old if such gigantic phenomena were already present in space 13.5 billion years ago? These discoveries go beyond our previous understanding of the formation and growth of black holes and galaxies and challenge the entire field of cosmology, questioning how massive black holes could have grown so quickly. Previously, we had hypothesized that black giants took billions of years to grow, but it appears that was wrong. James Webb is simply brilliant. No one expected it. The construction costs of this telescope kept skyrocketing, and the project was already on the verge of collapse. In the U.S. Congress, the project was described as sheer madness in the midst of an economic crisis, and the money was called a waste. However, the government stubbornly stuck to its plans. In the end, the James Webb Space Telescope cost nearly $11 billion. The costs were shared by the European Space Agency and the Canadian Space Agency. And as proof that it was worth it, this telescope is showing us the universe in a way that will change everything. The very first image was a brilliantly successful one that showed us that up until now, we were simply wrong. Webb discovered the record-breaking black hole thanks to the gravitational lensing effect. A cluster of galaxies located spatially between us and the black hole acted as a natural lens bent due to the warping of spacetime. The light coming from the black hole behind and from galaxy GNZ11 was amplified 50 times, and it is nothing short of a miracle that we are now able to capture the light that has traveled to us from so far away. Imagine that this light has traveled for over 13 billion light-years through space and time and then hit James Webb's observation mirror in the year 2023. Webb is able to capture these incredibly faint light signals, thanks to a completely new and highly sensitive infrared technology, and convert them into extraordinary images. Objects extremely distant and otherwise invisible in the universe suddenly become tangible, and we can see for the first time what really happened in the universe 13 or 13.5 billion years ago. Why does the black hole shine?
Are you wondering how it captures the light of a black hole if it is actually invisible?
Black holes are indeed invisible. Moreover, they are not black but transparent.
Normally we know them only because they extremely warp spacetime.
But black holes have another interesting property that makes them visible even at great distances.
The luminosity does not derive from the fact that these giants emit light.
According to the laws of physics, nothing comes out of black holes, not even light. But something enters black holes. Light is produced as soon as matter, such as stars, gas clouds, interstellar dust, approaches the black hole. Due to the strong gravitational force, all the matter is attracted and begins a spiral dance around the black hole. Scientists call this process accretion, and the accretion disk around a black hole that is consuming a meal can become so powerful that it overshadows the brightest stars. In a strict sense, the light is produced by the acceleration, friction, and compression of matter that will disappear into the mouth of the black hole, never to be seen again. This light is a real treasure for astronomers. The heating causes the matter to shine brightly at different wavelengths. Each wavelength provides scientists with details about the matter and the elements that are being devoured. And thus, thanks to Webb's fine sensors and special analysis algorithms, scientists can analyze exactly what is being disintegrated here. It might seem too absurd to be true, but black holes have even more massive feeding habits, and the jets are probably among the strongest. You can probably already imagine the enormous forces at play in the accretion disk when entire stars are broken down into spaghetti-like structures. These processes sometimes produce powerful jets of radiation that are blown out from the center of a galaxy into the surrounding area in the form of gigantic streams of particles. These jets reach nearly the speed of light and, like the accretion disk, can be very bright.
Researchers have discovered this within the black hole.
It's no wonder that we've now also discovered what happens inside a black hole, and you might be very surprised by it. Before revealing the mystery, let's take a quick look at the previous theory. Einstein's general theory of relativity predicted the existence of a singularity at the center of a black hole, a tiny point where all physically measurable magnitudes go to infinity. For this reason, it's hard to understand what a singularity really is. An interesting hypothesis might be that the dimensions of matter sucked into the singularity are reduced, or that even the values of the matter entangled, its heat, and its acceleration inside the black hole, go to infinity. It became interesting when quantum mechanics postulated that black holes cannot completely destroy matter. The information that once formed the matter must always be preserved. Stephen Hawking even demonstrated that this information is stored in a previously unknown form on the surface of the event horizon, and may be partially released in the form of Hawking radiation. One thing is certain: black holes get fat when they eat matter. However, it is hard to imagine that the giants store stars or gas clouds inside them. It is much more likely that only the information or a form of the basic matrix of the matter is preserved. But what happens then?
Researchers have recently discovered the incredible.
The extreme conditions of a black hole may allow the creation of a new universe within it. This means that our universe might have been created in a black hole, or born through a black hole. And now a gigantic black hole whose existence cannot be explained appears right at the beginning of our universe. It's fascinating to imagine what this means. It's possible that these extremely old black holes exist because they were there from the beginning, or because the entire universe was created by them. This way our cosmology would be revolutionized, and we would be at the beginning of a completely new story about the origin and true connections of our universe. Indeed, an infinite number of universes.
Let's take a moment to analyze the facts.
We have a very old and very large black hole, which according to ancient cosmology shouldn't even exist. Moreover, James Webb has discovered another 6 luminous objects that might be giant black holes. If this discovery proves true, these 6 holes could be even older and thus even closer to the Big Bang. We now know that black holes might have participated in the formation of our universe. And here is where the most interesting theory of the famous British astrophysicist Sir Roger Penrose comes into play. His conformal cyclic cosmology, CCC, as experts abbreviate it, asserts that the universe is finite in time, but is continually forming. At the end of one universe, one or a few black holes will have absorbed all matter. At that point, a moment of nothingness occurs and a new universe is born with a bang. We would thus have an eternal chain of births, lives, and decays of one or more universes. This bold theory has been stirring discussions among astronomers and cosmologists since 2005 and now has received a boost from the discoveries of James Webb. These images could be the first evidence of the CCC theory. An interesting question is how Roger Penrose came up with this idea. According to his own statements, the theory of conformal cyclic cosmology emerged in the early 2000s, even though the scientist only presented his detailed ideas in scientific circles after he had gathered enough clues and possible evidence. Penrose quickly presented his CCC theory as a coherent response to many unresolved problems of cosmology. For example, he explained the extremely fine homogeneity of the universe that can be observed through the cosmic microwave background and addressed the issues of dark matter and dark energy. Penrose disagrees with the idea of cosmic inflation and has presented other mathematically valid models in his new concept. However, one can imagine that Penrose's idea encountered strong resistance at the time. Those who protested loudly against the idea of a universe that continually recreates itself are precisely the scientists who now find themselves looking at Webb's images with long faces, describing these galaxies and black holes, clearly real, as impossible. The discoveries of Webb do not yet prove the CCC but open the door to new ways of seeing things and to completely new cosmological ideas. The images captured by Webb might just be the beginning of a series of discoveries that could revolutionize our understanding of the universe and its deepest mechanisms. The deepening of theories and observations from Webb will allow scientists to test the validity of various cosmological theories, including Penrose's conformal cyclic cosmology, in ways that were not possible until now. If further observations confirm the current hypotheses, we might find ourselves on the threshold of a new era in cosmological science, where old theories are questioned and new ideas take shape. The possibility that black holes might play a crucial role not only in the structure and evolution of galaxies but also in the birth of new universes is a fascinating prospect that stimulates further research and discussion in the scientific community. Ultimately, these discoveries remind us how little we still know about the universe and how vast and mysterious it is. Every new image and data we receive is a piece of the cosmic puzzle that scientists are slowly putting together, and every discovery is a step forward in our relentless pursuit of knowledge. This is an exciting time for astronomy and for everyone fascinated by the mysteries of the universe.
We eagerly await further updates from Webb and other space missions that will continue to push the boundaries of our understanding of the cosmos.
The story of the universe is still being written, and tools like the James Webb Space Telescope are the instruments with which we are beginning to trace its outlines.